11,000 meters beneath the ocean, there's a place darker than space, more hostile than any battlefield, and one country just made a discovery there that could shift the global balance of power. While the world looks up at the stars, something far more urgent is unfolding deep below, and no one is ready for what's coming. While the world races to colonize Mars, a quieter and far more dangerous race is unfolding right beneath our feet. Deep beneath the Pacific Ocean lies the Mariana Trench, the darkest, coldest, and most extreme place on Earth. At nearly 11,000 meters deep, it's a pressure chamber where light disappears, metal bends, and biology rewrites its own rules just to survive. For decades, the trench was a scientific curiosity, visited only by a handful of explorers. But now, everything has changed. China is moving in. Fast. While the United States slashes funding for deep ocean science, China is launching autonomous submarines, building permanent undersea bases, and extracting information and resources no one else is seeing. This isn't just about marine biology, it's about surveillance, energy, and control. What they're discovering down there could reshape energy markets, tilt military power, and even give them the upper hand in a new kind of global conflict. And the rest of the world is barely paying attention. So what exactly lies at the bottom of the Mariana Trench? And why is China so determined to control it first? To answer that, we need to go deeper, far deeper than most have ever dared. The Photic Zone. The Photic Zone is where the ocean begins, and where our understanding of it usually ends. It extends from the surface to about 200 meters deep. In this narrow layer, sunlight still penetrates the water, allowing photosynthesis to occur. That simple fact makes this zone responsible for over half of the oxygen we breathe, produced not by trees, but by microscopic phytoplankton floating just beneath the waves. It's also the most visually familiar part of the sea. Here, everything seems alive, colorful, and active. Coral reefs form underwater metropolises, housing thousands of species in tightly interwoven food webs. Dolphins break the surface, seabirds dive for prey, schools of fish shimmer like living mirrors, and humans play unaware above it all, swimming, surfing, snorkeling, assuming this vibrant skin represents the ocean as a whole. But the Photic Zone is a lie of comfort. It only accounts for a fraction of the ocean's true depth, less than 5%. Everything we can see with the naked eye, everything explored with traditional tools, exists here. Below it begins a world most will never see, a world where light disappears, pressure builds, and life begins to look like something from another planet. We leave behind the familiar and descend into the unknown. The Twilight Zone. Between 200 and 1,000 meters below the surface lies the mesopelagic zone, known more poetically as the Twilight Zone. This is where sunlight begins to die. It filters weakly through the water above, casting a perpetual dusk that gets darker with every meter. By 600 meters, it's almost gone. At 1,000 meters, it vanishes entirely. The creatures that live here have adapted to this half-light in remarkable ways. Some have evolved massive eyes to capture every trace of illumination. Others have lost their pigmentation altogether, becoming translucent or silver to reflect what little light remains. And many generate light of their own through chemical reactions in specialized organs, a phenomenon known as bioluminescence. Here, life turns surreal. The oarfish glides through the water like a serpentine banner of silver and red, reaching lengths of over 10 meters. Sailors once believed these fish were sea serpents. Seeing one in the murky blue, you wouldn't blame them. Then there's the sea angel, an ethereal winged slug that flaps through the dark with slow, ghost-like elegance. Despite its angelic name, it's a predator. It hunts using tiny hooks hidden in its translucent arms, feeding on other gelatinous creatures in the shadows. This zone is not quiet. It's alive with motion. Millions of fish and plankton engage in the largest migration on Earth every single day. As night falls, they ascend to feed near the surface. At dawn, they sink again into the gloom to hide from predators. This daily movement, called vertical migration, moves more biomass than the great migrations of Africa and the Arctic combined. And yet, for all its activity, the Twilight Zone remains one of the least understood layers of the ocean. Scientists estimate that over 90% of the fish biomass on Earth may live in this zone, mostly undetected, mostly unstudied. From here on, the descent becomes something else. At around 1,000 meters below the surface, we pass a threshold into the midnight zone. No sunlight reaches this far. None. You could shine the world's brightest flashlight and it would barely cut through the blackness. It's not just dark, it's endless. This is a place where pressure crushes everything not built to survive it, more than 100 times the pressure we experience at sea level. It's the equivalent of balancing a grand piano on every square inch of your body. And yet, here, life continues. It just looks nothing like what we're used to. The creatures that inhabit the midnight zone seem pulled from another world. Many produce their own light, bioluminescence. Some use it to attract prey, others to communicate, and a few to disappear entirely using counter-illumination, lighting up their undersides to blend with faint light above and vanish from predators below. Here, you'll find the Magna Pinnosquid. Its arms can stretch more than 6 meters long, dangling and curling like ghostly puppet strings in the deep. It doesn't swim, it hovers, waiting. Then there's the fang-tooth fish. Its teeth are so long it can't even close its mouth, but it doesn't need to. In the midnight zone, nothing wastes time or energy. Every adaptation has purpose. The black dragonfish has a jaw that glows. The barrel-eye fish has a transparent head and eyes that rotate inside like gimbals, scanning for silhouettes in the dark. And then there's the blobfish, infamous on the internet for its melting, sad-looking face. But that grotesque appearance only happens when it's dragged from the deep. Down here, in its native pressure-filled environment, it's compact, structured, and built perfectly for survival. The midnight zone is not barren, it's not dead, it's just hidden, and in many ways, still unexplored. In fact, scientists estimate that up to 90% of deep-sea species remain undiscovered. That means down here, right now, could be entire ecosystems, entire life forms that humanity has never encountered. But here's what makes this zone so important. It stretches across the entire planet. It covers more area than all the continents combined. It's Earth's largest living space, and yet we've mapped more of the surface of Mars than we have of our own midnight zone. And that's not just a curiosity, it's a vulnerability. Because while the world sleeps, one country is descending into this darkness. Not for science, but for something much bigger. As we descend beyond 4,000 meters, we enter a realm known as the Abyssal Zone. The name is fitting. It comes from the Greek word abyssos, meaning bottomless. It's a place of cold silence and apparent emptiness. Here, the temperature hovers just above freezing. There is no sunlight. The pressure is over 400 times greater than at sea level, enough to crush submarines not specifically built for this depth. It feels lifeless, but it isn't. At first glance, the seafloor appears plain, just endless stretches of mud and sediment. But that mud tells a story millions of years in the making. It's built from something scientists call marine snow, a slow constant rain of organic material that falls from the upper layers of the ocean. Tiny particles, bits of dead plankton, fish scales, fecal matter, microplastic, jellyfish remains. It all sinks, and it never stops. Imagine snow falling in a forest that no one ever walks through for thousands of years. Eventually, it buries everything, and that's what's happening here. In some places, this thick, soft sludge can reach over a kilometer deep. It holds carbon, preserves organic molecules, and captures fragments of the ocean's history in its layers. This marine snow is crucial for life down here. In the absence of sunlight, the organisms of the abyss depend on whatever trickles down from above. But life doesn't just scrape by, it adapts in extraordinary ways. Many of the creatures here move slowly to conserve energy. Some have no eyes because there's nothing to see. Others possess gelatinous bodies with no skeletons, making them more resistant to pressure. And then, once in a while, something massive falls, something that changes everything. A whale fall. When a whale dies and its body begins to sink, it becomes a payload of energy, one of the largest biological donations the deep sea can receive. As it descends, scavengers gather. By the time it reaches the abyssal seafloor, it is a beacon. First come the sharks, slow, silent, ancient species like the six-gill or the sleeper shark. Then hagfish, which slip inside the carcass through its soft tissues, consuming it from the inside out. Crabs and snails follow. Worms known as osedacs burrow into the bones themselves, extracting lipids. Bacteria multiply, breaking down fats and releasing nutrients back into the sediment. Around the whale's skeleton, a temporary ecosystem forms. Dozens, sometimes hundreds, of species gather to feed, reproduce, and compete. Some of these creatures may exist nowhere else, only around this one dead whale. Scientists have discovered entirely new species on whale falls, blind crustaceans, parasitic worms, and mysterious microbes that thrive on bone. This process can last for decades, one body, years of life. But it's a rare event. The deep ocean is so vast and whale populations so diminished that these ecosystems are few and far between, which makes them even more important windows into how life survives, even thrives, in the harshest places on Earth. And the mud they leave behind? It becomes part of the marine snow, part of the cycle, part of the story. But the abyss isn't the end of the descent. Below even this quiet world lies something stranger, a realm where pressure becomes unthinkable and the rules of Earth's geology bend inwards. The trenches. And what we've found in their deepest point is more than just biology. It may be the key to a new kind of power. Below the abyss lies a world even more extreme, one that barely seems part of our planet. This is the Hadal Zone, named after Hades, the ancient Greek god of the underworld. It begins at 6,000 meters below the surface and plunges into the deepest cuts of Earth's crust. This zone exists only in the deepest ocean trenches, where tectonic plates collide and one slides beneath the other in a process called subduction. These are not gentle valleys. They are violent scars on the seafloor, steep, narrow, cold, and crushing. The most famous of these trenches is the Mariana Trench. It stretches over 2,500 kilometers across the western Pacific Ocean, longer than the distance from New York to Denver. Its walls drop steeply, like the inside of a cracked planet. But it's not the length that has captivated scientists and nations alike. It's the depth. At the western end of the trench lies a pit within the pit, the deepest known natural point on Earth, Challenger Deep. Nearly 11,000 meters beneath the surface, it is deeper than Mount Everest is tall. If you dropped Everest into the trench, its summit would still be buried under 2 kilometers of water. The pressure here exceeds 1,000 times what we experience at sea level. That's the equivalent of having 90 full-grown elephants pressing on every fingertip-sized area of your body from every direction. And yet, life still exists here. In the cold, pitch-black, crushing stillness, pale amphipods, tiny crustaceans crawl across the sediment. Giant single-celled organisms called xenophyophores, some the size of dinner plates, lie half buried in the mud, filtering nutrients from the water. Bacteria cling to rocks, feeding on chemicals that seep through the trench walls. These organisms aren't just surviving, they're thriving under conditions that would instantly kill most life on Earth. They may hold clues to life on other planets, especially icy moons like Europa or Enceladus, where similar pressures and darkness dominate. But exploration of this place has been rare. In 1960, 2 men, Swiss engineer Jacques Piccard and U.S. Navy Lieutenant Don Walsh, descended to Challenger Deep in a steel capsule called the Trieste. They stayed for only 20 minutes before rising again. For more than 50 years, no one returned. Then, in 2012, filmmaker James Cameron made the journey solo, capturing high-definition footage and samples. Later, private explorer Victor Vescovo dove multiple times in a state-of-the-art submersible, gathering scientific data and making new discoveries. But all of these missions had something in common. They were rare, costly, and isolated. Until now. In recent years, something has changed. The world has started to pay attention, not just to the trench's scientific mysteries, but to its strategic value. Because beneath all this crushing water lies more than strange creatures and sediment. There are resources, energy, data, infrastructure, a frontier that, if controlled, could reshape global power, and the country making the boldest moves into this underworld is China. For decades, the depths of the ocean were visited only by pioneers, visionaries, and the rare explorer with enough funding and obsession to reach the bottom of the world, the United States Navy. Independent billionaires, a Hollywood director. Each mission was historic but temporary. A single dive, a brief stay, a quick return. Then came China. In 2020, China launched its own manned mission to the bottom of the Mariana Trench using a submersible called Fenduzi, meaning striver. It was their deepest dive ever. The mission made headlines, but what mattered wasn't the descent. It was what came next. Unlike previous expeditions, China didn't treat the trench as a scientific trophy. They treated it as a strategic asset. In the years that followed, they shifted their entire approach, from rare, expensive dives to a systematic and scalable operation. Instead of one massive submarine, they began building fleets of small, autonomous robots, agile, reusable, designed not just to explore, but to operate. These vehicles require no pilots, no human life support, no surface cables. Some are the size of torpedoes, others no bigger than a shoebox. They can dive, scan, collect, analyze, and return again and again. What used to take years of preparation and millions in equipment is now being done on a weekly basis, quietly, repeatedly, efficiently. With each mission, China is building something more valuable than any one discovery: presence. Presence leads to data, data leads to mastery, and mastery leads to control. By 2024, they were not just mapping parts of the trench, They were studying its currents, its chemistry, its biology, and its weak points. Submersibles were sent in waves, some equipped with mechanical arms, others with sediment samplers, sonar arrays, or AI-driven navigation systems. These were not prototypes, these were systems. What this means is that China is no longer just exploring the deep ocean, they are positioning themselves to occupy it. And unlike space, where every satellite and launch can be tracked, much of what happens beneath the sea goes unseen, unmonitored, unchallenged. While other nations debate budgets and cut funding to ocean research agencies, China is pouring investment into underwater infrastructure, robotics, and long-term strategy. And the implications are staggering. Because this new generation of submersibles isn't just scientific, it's dual use. The same robot that collects sediment can also tap into cables. The same drone that studies ecosystems can be reprogrammed to scan for enemy vessels. The same data that maps the sea floor can be used to control what happens beneath it. This is the silent frontier of global competition, and China is diving deeper, faster, and with more purpose than any nation in history. So, what exactly is China looking for at the bottom of the ocean? What's hidden beneath the crushing pressure and eternal darkness that's worth this level of investment, secrecy, and urgency? The answer is complex, but it begins with something invisible. Energy. Cold seeps. In some of the deepest parts of the ocean floor, strange geological formations called cold seeps leak methane and hydrogen sulfide gas from beneath the seabed. They don't bubble like hot vents, but they quietly sustain entire ecosystems. Life here survives not from sunlight, but from chemistry. Mussels, clams, and giant tube worms live off the gases released by the Earth itself, thanks to bacteria that convert these chemicals into energy. It's called chemosynthesis, and it's one of the most fascinating biological processes on the planet. To scientists, cold seeps are windows into how life might exist on other worlds, like Jupiter's moon Europa or Saturn's moon Enceladus, both believed to harbor oceans beneath icy crusts. To China, cold seeps represent something else, a biological and technological testbed. If they can study how life functions in these extreme conditions, they can begin designing systems that survive them, that has implications for long-term deep-sea operations and for future space colonization. But more than that, these seeps hint at untapped sources of energy, and that leads us to something even more controversial: methane hydrate, fire ice. Beneath the cold mud of the sea floor lies a frozen substance that looks like packed snow, but if you light it, it burns. It's called methane hydrate, or more dramatically, fire ice. It forms when methane gas becomes trapped in cages of water molecules, stabilized by low temperatures and high pressure, and the amount of energy locked inside it is staggering. A single cubic meter of methane hydrate can release over 160 cubic meters of natural gas. Some experts believe methane hydrates could be the next major energy source, a bridge between fossil fuels and renewables. Others see them as a climate nightmare waiting to happen. If disturbed carelessly, these formations could collapse, triggering underwater landslides and releasing massive amounts of methane, a greenhouse gas dozens of times more potent than carbon dioxide, into the ocean and atmosphere. And yet, China is testing extraction methods cautiously, persistently. They're building the tools, laying the groundwork, preparing to do what no other nation dares to attempt at scale: polymetallic nodules. But energy isn't the only treasure hidden in the deep. Scattered across the abyssal plains are thousands, perhaps millions, of strange, lumpy rocks called polymetallic nodules. They're about the size of potatoes, but inside, they contain some of the most valuable materials in the world: nickel, cobalt, manganese, and rare earth elements, the essential components of electric vehicles, batteries, smartphones, and renewable energy technology. Mining these nodules is a technical and environmental challenge. Specialized machines must crawl across the seabed, vacuuming up sediment, sifting out the nodules, and pumping the material back to surface ships through massive vertical pipelines. But the process leaves destruction in its wake. It creates massive plumes, clouds of sediment that can smother fragile ecosystems, drift for kilometers, and disrupt life that took millions of years to evolve. The long-term effects of this are unknown, but China is moving forward, developing technologies not just to mine more efficiently, but to mine first. And in a world increasingly driven by technology, whoever controls the raw materials controls the supply chain. From cold seeps to fire ice to rare metals, the deep sea is no longer a realm of mystery and science fiction. It is a resource frontier, and China isn't waiting for permission. They are already down there. China isn't just sending robots into the deep. They're preparing to send people and keep them there. In 2021, China revealed plans for a permanent underwater base to be installed 2,000 meters beneath the surface, a manned station capable of housing up to 6 scientists for 30 consecutive days. Think about that. Not a submarine, not a research vessel, a habitat fixed to the seafloor, operating like a deep-sea version of the International Space Station. The purpose isn't just science, it's presence. The ability to monitor, extract, and experiment in one of the most inaccessible regions on Earth in real time. Living at that depth requires advanced life support systems, high-pressure resistant engineering, and complete autonomy from surface supply chains. But China is developing all of it, quietly and aggressively. This base would allow continuous research, training for long-duration missions, and most importantly, exclusive access to whatever is discovered down there. Other nations talk about returning to the moon. China is planting its flag beneath the ocean. And in a race this silent, whoever gets there first doesn't just explore, they define the rules. Beneath the seabed lies something even more valuable and more vulnerable than energy or metals: cables. Running across the ocean floor is the invisible infrastructure of the modern world. More than 95% of global internet traffic, emails, bank transfers, military communications, even the video you're watching right now, flows through undersea fiber optic cables. They're wrapped in steel, laid by ships, and stretch thousands of kilometers between continents. But they're not buried, they lie exposed, and despite being as thick as a garden hose, they can be easily damaged. Sometimes by accident, a ship dragging anchor, an earthquake; other times, by design. In recent years, Western intelligence agencies have tracked Russian vessels lingering near key cable routes in the North Atlantic. The concern: sabotage. A well-placed cut in a transoceanic cable could sever communications between entire nations. Now, China is entering this domain with its own deep-sea robotics. In 2025, they unveiled a cable interaction submersible, officially designed for underwater maintenance and inspection. But experts notice something else. It's equipped with a cutting mechanism. On paper, it's for repairing damaged lines, but in practice, it could be used to disable global internet traffic, disrupt financial markets, or compromise military data streams, silently, thousands of meters below the surface, where no one can see it happen. And unlike satellites, deep-sea activity is difficult to track, harder to verify, and nearly impossible to stop in real time. This isn't just theory. In 2022, internet access was disrupted across parts of Africa and Asia when undersea cables were mysteriously severed. No one ever took responsibility. No one ever proved sabotage. But the message was clear. The world's digital nervous system is fragile, and China is now building tools, not just to explore it, but potentially to control it. The battlefield of the future may not be in the skies or in cyberspace, but at the bottom of the sea, out of sight, out of reach, and increasingly, out of balance. At the core of every deep-sea mission, every submersible, and every discovery is a human mind. And right now, China is investing in those minds like no other country on Earth. They're building massive ocean research institutes, funding national programs in marine robotics, and offering elite training to a new generation of scientists, engineers, and biologists. The goal isn't just to explore the ocean, it's to create the workforce that can dominate it. And they're not stopping with their own citizens. China is actively recruiting international talent, offering grants, access to cutting-edge labs, and long-term research support to experts from around the world. While other countries tighten budgets, China opens doors. Meanwhile, in the United States and much of the West, ocean science is being quietly defunded. Key institutions like NOAA are losing support. Deep-sea missions are delayed. Some of the world's best researchers are leaving, not because they've lost interest, but because they've lost funding. And here's the consequence. Without investment in talent, the technology stops, the innovation stops, and leadership shifts. We tend to think of dominance in terms of ships, weapons, or territory, but the real battle is happening in classrooms, in research labs, and in quiet government offices deciding which projects live and which ones die. Because when one nation trains a generation to master the oceans, and another trains theirs to ignore them, it's not hard to see who will control what lies beneath. We've mapped the surface of Mars in more detail than we've mapped the bottom of our own oceans. But that's not just a scientific curiosity, it's a strategic blind spot. While world powers focus on the stars, China is quietly claiming the deepest parts of Earth, building the tools, training the talent, setting the pace. And here's the truth no one wants to admit. The deep sea isn't empty, it's rich, with energy, with metals, with secrets, and whoever controls it controls the infrastructure of tomorrow. But there's a cost. Once disturbed, deep-sea ecosystems can take centuries to recover, if they recover at all. Some species down there may have never been seen by humans, and may vanish before they ever are. We're standing at a crossroads, between exploration and exploitation, between progress and irreparable damage. The ocean has always been Earth's final frontier, but now it's becoming a battleground. This isn't just about science, it's about power. And the balance is shifting, fast. So the question we must ask isn't just who will get there first, but what will they do once they do? The deeper we go, the fewer eyes can see. And in the darkness, the rules are rewritten. What's coming next might not happen in the open, but you will feel its impact, whether you can see it or not. If you think what we found in the Mariana Trench is unsettling, wait until you see what's waiting just beyond Earth.